Okay, looking at example 2, solve by graphing y equals 2, y equals x. Now something I didn't mention on the first problem that I probably should have was both of those were slanted lines because both of those had a y and an x variable in it. If you take a look at y equals 2, there's no x. Alright, so let's consider if we have the x-axis is right here and the y-axis is right here. And again, we label those x and y, just creating that habit where we always do that. Okay. Y equals 2 is giving us a specific criteria for y to follow. Y has to equal 2. So the height of this graph is 2 always. X is not included in this, which means x is free to be whatever it wants to be. X could be 1, y has to be 2. X could be negative 3, y has to be 2. X could be 6, y has to be 2. X could be 0, y has to be 2. X could be negative 2, y has to be 2. No matter what x is, y has to be 2. So if you take a look at what that creates, everything's too high and you're free to move left and right as much as you want. You create a horizontal line. So y equals number just creates a horizontal line every time. That's why it does it. If you just get in the habit of knowing that y equals number is a horizontal line, you just graph a horizontal line when you say y equals number. Similarly, if it says x equals number, that just creates a vertical line. X equals 5, vertical line at 5. 1, 2, 3, 4, 5, up and down. Alright, that's how you graph a horizontal or vertical line. Every other line that has both x and y in it, we have to do normal graphing. So, y equals x is the same as y equals 1x plus 0. And if you want to get the slope-intercept method of graphing, it's helpful to have it in a form that has a slope and a y-intercept to look at. This time we have a y-intercept of 0, which is the origin, and a slope of 1 over 1, which is either up 1, right 1, or down 1, left 1. Get as many points as you want. If we connect those dots with a nice straight line, like so. And again, our job when we solve by graphing is to identify the point of intersection of the two lines. These lines intersect 2 spaces to the right, 2 spaces up, so the correct answer to this is 2, 2. One thing you can do to check your answer on these every single time is real simple. If this is the correct answer, x equals 2, y equals 2, both of these equations should be made true by this answer. So if I take this y and replace it with y's answer 2, 2 equals 2 is a true statement. If I replace y and x with x and y's values here, 2 equals 2 there also, both are right, correct? Going back to the original problem that we did, example 1, the answer we got here was 1, 2, right? So x equals 1, y equals 2. 2 equals 1 plus 1, true. Y equals 2, x equals 1. Negative 2 plus 4 equals 2, true. Right? So again, you can very easily check your answer to these every single time. You get an x, you get a y. Verify them by sticking them both back in the original problem. They should be making both of those equations true every time. So again, solve by graphing, graph both lines, find the point of intersection, identify the answer as an ordered pair. That's what we're looking for.